Today we're going to take a look at the path sum problem. So given a root of a binary tree and a target sum, we're going to return true if there's a path from a root to a leaf having no children. That adds up to the target sum that is passed in. We don't care about where it is, what it is. We just need to return true or false. So in this example here, we can go from 5, 4, 11 to 2. That adds up to the passed in value 22, and we'd return true. Okay, so the first thing to think about here is how are we going to solve this problem? It can be solved iteratively. It can also be solved recursively. In this video, I'm going to do the recursive solution. That's what came to me first when thinking about this problem. Is I know we need to explore multiple paths. So we see the solution here from 5 down to 2, but we're also going to explore the path 7 and, on the right side of the tree as well. So we're putting different calls on the stacks and keeping track of values and evaluating both the left and right side essentially. So I think recursion it can be applied well here. So I guess first of all, I like to use helper functions with recursion, especially just the way that lead code kind of has this set up. Like I want to use different parameters in my helper, etc. So I'm going to make a helper function. I'll just call it helper path. And then going to pass in the root and the target, of course, but I also kind of want to keep track of the sum so I can compare when we reach the sum or not, and just keep track of where we are. So we'll do that. Here I'm going to initialize the sum to 0, and then I'm just going to return a call here. Again, like a helper function is not really necessary, but just kind of to simplify things, I'm going to use one. The root will still be the root, and then target will be the target, and then sum. Okay, so then in here, if that root is null, we can just return false right away. We don't need to worry about anything there. So just going to get rid of that case. If root, if not root, return false. We need to also keep track of the sum, and we need to increment it with the current root's value each time. So again, we're going through the tree, we're making calls on the stack. We're going to want to know what is the target at, have we reached it or not? So we'll use that sum. Okay, so then we can use that sum and we can say if the sum is equal to the target, we'd want to return true, right? So it's not entirely true because we need to make sure that the root that is being passed in is a leaf. This should probably better be called node. So let's change that because it's not like always going to be the root. But anyways, so let's see if the node is a leaf or not. We'll have a variable called isLeaf, and we can set that equal to whether or not the node has a left value. Or if it does not have a left and it does not have a right. So if there's no left and there's no right, it's a leaf. So if the sum is equal to the target and isLeaf, we'll return true. And then otherwise, if not, let's return a call to helper path on the left and the right. So what it should actually be is node.left, or again, call the function on node.right. And then if either one of those ends up being true, we don't care which path you take down, but if we do end up at a leaf and we've reached the target sum, we should return true. So let's run that. All right, looks good here with the test case, which is this tree on the left, and then we'll submit the whole thing. Nice. So that is how to solve the path sum problem recursively. Just a couple things to note here. Make sure that you are returning the calls to the helper function. If you don't return anything, this is not going to work out. Also, make sure that you do check the leaf condition